For our exercise 8, we will load an image and we will extract data from that image, namely color data, to create new geometry based on that image. Okay. So first we need an image. So I'm going to Google, I don't know, Helsinki and see what we get in terms of imagery. Images, and I want images with kind of more liberal rights that we can reuse it for non-commercial purpose. So for that we're gonna go to tools and usage rights. We would pick non-commercial reuse, and let's see what we get here. So maybe I'm gonna use something like this, Tomio Kirko. Yeah, I think this could be good. So how big is this image? It's quite huge. So maybe sorry about that. Maybe I should pick size medium, something like that, something which is more usable. And what about this one? Okay, this is more manageable. So I'm going to download I'm going to download this image, save the image to downloads. Here we are, and I'm going to put it in my desktop for now. Okay. So far so good. Now I need to open my project generator, not mine, I mean the project generator, and we're going to open it, and I want to point it to the folder that I'm working on, which is not the default My Apps one, but it's the GMC folder. Feel free to keep using your My Apps. And the kind of syntax we've been using for naming convention has been exercise number dash and now image pixels. Okay. So I'm going to generate this, and I'm going to open in IDE. This will open Xcode and with the files I need, except of course my image file. So I'll go back, and here now I have a newly created ImagePixels file, and I need to put my image inside the bin data folder. So I'm going to put it there, and I am going to copy this name to be pasted later when we get to load the image. So if you remember what we did for the font file, we loaded a font file and we put it in the bin data folder, right, where it's accessible to be loaded by openFrameworks. We need to do something similar with image, and exactly how similar? Well, we need to check the documentation. So we go to the graphics module, and then of image, we have very useful things, right? So for example, we have load, which we will use to load the image to our object container. And then we have draw, which we will use to display it on our window. And there's other things that we're going to use. So get pixels kind of dismantles the image into each of its pixels, right? And this can be quite useful for us. So that one is also useful. And we will also use get width and get height of the image to calculate its size, so that we can put things side by side, or we can calculate what kind of size we need to redraw that image as geometry next to it, right? Okay, so I think we have what we need, at least to load and display the image. So we need an image container of image class, and I'm gonna call it my photo, for example. Okay, my photo. So now remember the steps for loading the font. We create the container, step number 1. Step number 2, we load the file into the container, and I have it in my clipboard, I think, yes, the name of the file. And now in draw, we draw it. I'm going to draw it in pixels. To keep things simple, I'm going to draw my photo in pixel 0, 0. Okay, just in the top left corner of the screen. And I'm going to run this. So when I run, I should have a photo of Helsinki in the top left corner of the window and some empty space next to it. So let's see what we get. Here we go. We have our image there. Okay. So I want to draw another image to the left of it. So I have to either I can scale the image. There's a resize function to scale it, but I'm actually lazy to do it, and I'm going to actually double the size. I mean, it's not just laziness. I want to keep the exercise relatively simple. But you know, I can show you the resize function resizes images to a new width, a new height. I could use that, but instead I'm going to increase the size of my window, maybe 1,800 pixels. Okay. So that was in the main CPP. So now this was simple. It was just loading the image and displaying it. But how do I get the pixel information that I need to get the color of each pixel so I can draw things with new things, but with using the color information from that image? Well, in the openPixels class, which is here, we have something called getColor. So if we match getPixels, which is in the image class, with getColor, we can get the colors of pixels. But first we need to get the pixels, then we need to get the color. Okay? So let's do this. So where do we get the pixels? Where is a good spot to get the pixels of the image? Well, openFrameworks should load image fast enough because it's locally stored. So it should load it fast enough that in setup, just after I load it, I can retrieve the pixels. It might not work for huge images because it will take some milliseconds to load, and that's not quick enough to get the pixels. So for small images, I would say put it in setup. For bigger images, you need to put it in update because you need to kind of to preload the image before asking for the pixel information. So then I need to create an openPixels object that's going to store my pixel data. So openPixels, I'm going to call it my pixels, for example. I could call it anything, photo pixels or anything like that. I'm a little bit unimaginative with naming sometimes. So what we need here is my pixels we need my pixels equal my photo get pixels. So with my photo get pixels, we are extracting the pixels from my photo and we are storing it in my pixels. That's why we made my pixels global, because we need to make my photo global. We need it in two different functions. We need it in setup and we need it in draw. Because it's in draw that we're going to get the color information to draw new things. So always remember, we need to make as a rule of thumb, we need to make variables global when they're used in more than one class. If they're only used, more than one function. If they're used only in one function, you can keep it local to that function. So what I want to do, I want to draw the my photo, and then next to the photo, I want to draw, for example, a pixelated version of that photo next to it. So how to draw a pixelated version of it, basically a pixelated version of a photo is a grid, right? It's a grid of pixels of a certain size. So we saw this in the previous exercise, in the Perlin 2D exercise. We created a grid. And how did we create a grid? With a nested for loop, a for loop inside another for loop. We need a for loop for the x-axis, we need a for loop for the y-axis, right? So let's get to it. For int x equals 0. So we want to sweep through the image, and for each of its pixels, draw something next to it. So we need a for loop that sweeps through the picture. So we can, to sweep through it, we need to go from pixel 0 to the last pixel. What is the last pixel? So x lower than the last pixel. The last pixel is my photo dot get width. We can ask openFrameworks to get us that information. We don't need to memorize it or take notes or whatever. We just ask. And for now, we're going to go pixel by pixel. So x plus plus, meaning that we're going to go pixel by pixel and sweep the whole x-axis of the photo. And for each x axis, we're going to go through the y-axis. So for int y equals 0, y lesser than my photo dot get height, and then y plus plus, right? And for all of this, we will, for each of these pixels, we'll draw a rectangle. For each pixel, one rectangle, okay? So we're gonna do of draw rectangle, and this rectangle will be, what will be the float? It will be x and y, and the size of this rectangle will be 1. So the rectangle will mirror 1-to-1 the pixels of the image. But if I draw it in x, it will be drawn exactly on top of the old image. So I want to put here x plus my photo get width, so that it's drawn next to it, not on top of it. So what are we going to, we didn't change any color. So if we didn't change any color of the rectangle will be drawn in white. That's the default color. So what I expect to get when I run is the Helsinki photo, and then next to it, a series of white rectangles which will be contiguous, so it's gonna look like a big white rectangle next of the same size of the image, right? This is what I'm expecting to get. So let's see if that's what is going to happen. Yeah, there we go. We get the Helsinki image, and then we get the white, because it's the same size, so something is working well, but the color information is not correct. We need to add the color information. That's why we extracted the pixels there. So each pixel will be of the same color as the original pixels, right? So offset color, and then we have my pixels, and we can get the color of pixels, and we can get it in these two dimensions, x and y. So x, sorry, I want to jump with the tab, but it doesn't let me. X, y, okay, semicolon. So we get the color of each pixel of the original image, and for each rectangle will have the color information of the correspondent original pixel. So let's see if that's what happens. Yeah, here we go. Did you notice a little change of color here on this image? I'm going to tell you why that happened. So the color is defined top down. So when you set a color in the top of your program, everything which is below that offset color will get that color. And it kind of goes back from the end to the beginning. In the next frame, that color information will also be used for the new drawing. So because my image is being drawn with the last color that was defined for the rectangle. So I need to have here to kind of clean up the color palette, I need to draw this image as white. So white is the neutral color. Any other color definition will tint our image, or the image we are drawing. And if I'm not mistaken, that's the same for video as well. So yeah, now that weird phenomena didn't happen, right? And just to demonstrate my point, this is a bit silly, but just to show you this tinting phenomena in action, I can show you now. Now I set color red, so that image should be a little bit reddish, right? It is reddish. But if I had put a set color red here, first it will draw it normally, then it would draw all the rectangles, and then in the next frame it would draw it in red. So just a little disclaimer or warning: when you deal with set color and image, it can play tricks on you. You see? So I am gonna put this back here, and I'm going to put it back to white. Great. So this is not very exciting, right? Why did we go through all this trouble to draw an image which is exactly the same thing as the previous one? So so this here is the original image, and this is kind of the new version of the image. So let's play with this a little bit. Let's pixelate the image. Instead of drawing these squares of 1 pixel size, why don't we make them bigger and create this kind of pixelation effect? And that could be fun. So let's create here a float which is the size of the squares, and let's make it 5. We can change it later. And here, remember how we did it in the previous exercise. Instead of jumping one by one, we're going to jump size by size. So size, we're going to add size here. We're going to add plus equal size there. And here, instead of 1, this will going to be size. So size will define the size of our pixelation, so to say. But the thing is that if you have a grid of 5 by 5, the color that is going to be picked is that color. So you can think of get color as a color picker, right? So get color of pixels. Actually, the example that we have here is using the mouse as a color picker. You can use the mouse as a color picker in an image, and that's basically what we're doing. But we're sampling the top left corner of our virtual square in each of the squares of this grid, right? So what I'm expecting to get now is then the second image, the right image, will be kind of a pixelated version of the previous image. And of course we can play with this size, right? We can have 20 instead of 5, and it could be a bit more fun, I guess. It's going to be more and you can play a lot with this. Of course, pixelation is just one option you get. You can create random geometries, a collage of random geometries with with information from the image. You can play with this and do a lot of interesting, crazy stuff. So instead of drawing rectangles, you can draw circles, circle. But then you don't need. But bear in mind that size will be the radius. So, and what we need is it's going to be probably too big. So the size is the diameter, and what we need is the radius, right? So I want, yeah, this is twice as big as it should be, because what I want is this divided by 2, and then we probably have a neater. So now we have circles instead of squares, right? And you don't even need, if you don't want to draw the original image, you don't need to draw it, right? You can just have the new image and even draw it then in the corner. Then you don't need this. Right? You can start drawing the circles in the corner. Right? So you don't need to draw the original image to get its pixels. The pixels are obtained in the setup, right? And you can even scale the image, right? You can scale it. So okay, so now it's a little bit more interesting. So what if we scale this? Because now these are vectors, so we can scale. So we can have like a zoom. What if we scale this by a factor? So we can call this zoom, and let's say that zoom is 2. So then size is size times zoom. Okay. So that should do the trick, I think. Let's see. We need xy to multiply it by the zoom as well, right? We need xy to be multiplied by the zoom. So let's do that. X times zoom and y times zoom. And then we're going to spread the image much more. Maybe 2 is too big, but I think you get the point where we can get with this. So what if we multiply here? This is where we need the zoom, I think. And 1 is maybe a bit too much, or we can even map this to the mouse. So of map mouse x, which goes from 0 to of get width. So by moving the mouse in the x-axis, we could affect the size of the image between 0 and 2, let's say. So I have a typo here, of get width. So let's see what we get. So by moving the mouse, I can increase, and of course, because this is now kind of vector graphics, it's not pixels. It gives the illusion that we are zooming, but we are not. We are just scaling the image. We're not getting more information. The pixels are the same, but I can play now with the image, right? So you see, this offers a lot of potential and interesting possibilities, and of course, the smaller the size, the more you sample the original colors. So it depends on how much kind of pixelated, let's say you want this, right? So this is with a kind of a smaller cells in the grid, right? And that's basically it. I mean, we could do we could play a lot with this, but I think I'll leave it like this. And in the lecture, if you have any suggestions where you want to take this exercise, we can take it. And of course, we can always bring back the old one, right? We can always bring back the old one. We can even put it a little bit darker. So just to we can use the color. So to put it 50% darker. And the way draw works is that the first thing that gets drawn goes to the bottom. Then what you draw next goes on top of it, right? So if I bring the old image back, now I have the circle kind of version of that image on top of my old image, right? It's a little bit darker because I made it darker through the off color, right? And now we have the old one and the new one. And that's it for this exercise, or for this version of this exercise.